Okay, so we're going to talk about lambdas today. Lambdas can be pretty confusing when you very first get introduced, and hopefully after this, the mystery will be gone. So lambda, I'll just say really quickly, a lambda is just a representation of a function, some some set of instructions uh, for a program that can be passed around like data. So instead of passing data, you're passing some instructions to execute on some arbitrary data that someone else may have. So let's start by just making a little TypeScript program, and I like to do that. I like to show you how to do it just so you get in the habit of making these little play programs in TypeScript. So this is just going to be a console application. So I'll make dir lambdas, c lambdas, npm init -y, so it fills in all the stuff for you. Then we'll code to bring up VS Code. Now I need to add that as a window here. Just a second. Window capture, VS Code. Okay, and then we'll capture that one. Okay. All right, and then I will make this wider so that we can make it bigger on the screen. Okay, there we go. So there's our coding. And all right, so now we have this package.json. Let's do some installing. So npm install for developer mode. We want to bring in Typescript, TS node, and the types for node. That just the types make it easier to see what's going on. Okay, that was painless. Okay, so now up here in the code, we've got this package.json. We need to have a start script here. We'll call this one TS node. Okay, we need to say where we're going to put this file we're starting from. So we'll say src index.js, no, ts. And then we got to create it. So we're going to come here, new folder, src, and a new file, index.ts, and I'll just put something here, console.log, hello. And then the last thing that we need is we need a ts config file .json, and I just keep handy the kind of config I want. It's just too hard to remember all this stuff. This is a pretty generic ts config. These aren't all the settings I typically use, but they're good enough for our purposes today. So I'll do that here. And all right. Okay, so now we're ready to just run it with an npm start. Should get a little hello. There it is. And then I always like to make sure that I can debug, because it's a little easier than running printf. So I put a little breakpoint here in VS Code to go here to the debugger tab. I hit run and debug, and just do a simple Node.js. And we should hit this breakpoint. There we go. All right, so our debugging is working, so that's great. Okay, so to talk about lambdas, let's just talk about what a function is off the top. So we're going to just make a function here. So a function is something that takes some arguments. So this one will take some number. We'll call it I, which is some number. And then it will do something. And so in this case, we might say return I plus 10. Oh, we've got to give the function a name, of course. We'll call this function add 10, and now we'll call it. So we'll say our value is equal to add 10, 5, and then we'll console.log the value, and we should get, of course, 15. Okay, so we got it. That's working like we expect. Okay, so let's look at what this program is doing here. So as the interpreter is moving through this code line by line, it's skipping the first two lines because there's nothing. Then we see a function. We're not actually running anything. It's just defining the function. So this function will not get run if we don't actually call it. And I can prove that in the compiler easily enough. So I can just say, I'll take out these two lines, and then I'll say, console.log end, and then I'll have a breakpoint here. I'll hit this breakpoint, but if I put a breakpoint inside the function, it won't break. So we'll do a run and debug, and yeah. So we got to the end of the program, but we never hit this. So when the compiler is, or the interpreter is moving through these lines, it's not actually running any code. It's just remembering the code that's here. And then we get to the end. Okay, so this is our function, but when we add this line here, now this is calling the function. And so that's pretty basic stuff. Well, anyway, so, all right. So what's cool is we can now pass this function somewhere else as an argument. So let's do something here. And so that this is easy to follow, I'm going to put here console.log add 10, just so we can see that this function gets called. And I'm going to make a new function here. Function. We're going to call this do thing. We don't know what the thing is, but the do thing needs an adder. Okay, and an adder, we got to give it a type. Now this type is going to be a function type. So the function type is some parameters, like right now this is no parameters, points to something that returns something. And so we could say this should return a number. And then this function here will have a body. Okay, so now doThing is requesting a function as an argument. And we'll come in here, we'll put console.log. We're inside doThing, so you can see where it is. And we're going to have doThing return, 10 times adder of, actually we'll just return the adder of 6. So, I mean, this isn't doing anything interesting yet, but this will show you what's going on. Okay, adder, it doesn't know how to take a 6, so let's have adder take some value that's a number, and it's going to return a number. So now we can call doThing. So we can say const output is equal to doThing. Okay, now doThing wants a function that takes a number and returns a number. Well, add 10 is a function like that. So we can call add 10. Now you notice I didn't put any parentheses after add 10. If I did this, it doesn't like it. This is why I like doing Typescript, because it tells you when you're doing bad things. Add 10 returns a number, but doThing doesn't want a number. doThing wants a function. that takes a number and returns a number. So add 10 is just, this is calling add 10 and returning the result and then passing it to do thing. That's not going to work. So we need to just pass add 10. So let's think through what's going to happen here. I always like to treat these like interview questions. These are good interview questions because they get people to read the code and think about the state, like what's happening inside the code. So we're coming in here, the interpreter is reading this, it's not running anything. It reads this, it's not running anything. Here, it's going to run do thing. It's going to pass this function to it. So the next line that it executes is going to be up here. And in fact, we'll run the debugger so we can watch it happen. So let's just see the output. So what we expect is we're going to pass add 10 to do thing. Do thing is going to return whatever the adder is, 6. And so that is, we add 10 here. So we're expecting 16 to come back from output. So let's do console.log fact, yeah, and we'll just log output. And then let's see what happens. So if I run it down here, we're expecting 16, and there it is. So we saw that it entered do thing, and it entered add 10. So let's run it through the debugger and watch that happen. So we'll put the breakpoint here, run and debug. Okay, so here we are sitting on this one. So we'll trace into this guy. So now we're in the next line of code. We're up inside do thing. It's going to do that. Oops. It's going to log the output, and we're looking at the console. Yeah. So there's what we see, and then it's going to return. So we're going to trace into this adder, and next line of code is here and add 10. So the adder is this function. And then we return I plus 1 or I plus 10. And now we're back here to return the value we got back. And now we're here to log the output. And if we hover over output, we see that it's 16. So that's how the flow goes. So let's change this up a little bit so you can see more of what's happening here. We can make another function called add 20, right? And these are trivial. So we have some I number, and we'll return I plus 20, and we can do the same thing. So we can say console.log do thing with add 20. Boom. And we should get 26 back. So we run here, we'll see a 16 and then a 26. Yeah, there they are. So 16 and 26. So we can change the way do thing behaves by passing in a different kind of function here. So that's what's going on. Okay, so let's get rid of these functions, because now we're starting to get into where the power of Lambda gives you some interesting flexibility in the code. So stop debugging. Okay, so we don't know what add 10 and add 20 are anymore, and I'll just leave this line here. Well, what you can do is you don't actually have to declare a function and pass it in by name. You can actually pass in an anonymous function. And this is where the word lambda comes from, because the lambda is referring to this anonymous function. So this is so here are the arguments I'm passing in. It needs to have a number. And what's cool is because the interpreter knows that this guy is expecting a guy that takes a number, I don't have to be formal. I don't have to say n is a number. I can just say n. In fact, I don't even need the parens. I can just say n points to n plus 100. So I'm making this my own special adder there. So this should return 106. when we run it. And let's get rid of this turd here. So now we have this very simple program. We have a function that takes another function, and we define the function right here inside this. So let's run it. $106, just like we expected. Okay, now this function can be like arbitrary complexity, right? So we can actually give it curly braces, and then we can come here and we could just say, you know, const output is equal to, I don't know, date.now mod 100 return output. Okay. Plus n. I know that's kind of stupid, but we'll do output times 1000 plus n. Okay, that's silly, but we'll run it here, and we'll see that every time we run it, we'll get a different number with a little 006 at the end because we're doing this funny calculation. So yeah, this can be a whole complicated set of stuff, and then you can, as long as it meets the requirement of the interface. Okay, so next, all right, so let's take this up another level. So, okay, so now we're going to talk about closures, and this is another challenging concept, but pretty easy once you see how it works. So we're going to, we'll keep this do thing here that returns the adder of 6, and we're going to keep, we're going to make a new function here called make adder, and we'll have a start value. That's a number. Okay. Now this guy is going to return a lambda. So it's going to return a function. And you can do that. I mean, you can say return a function. Yeah. Here is trivially, it's returning a function that does nothing and returns nothing. So I could come in here and I can say do thing, instead of writing a lambda here, I can say make adder 10. Okay, now it's unhappy because this function it's returning is not the kind of function it's expecting here, and you'll see that in the Typescript. It says, a parameterless function that returns void is not assignable to a function that takes a number and returns a number. So this guy needs to return a function that takes a number and it returns a number. Okay, that's boring. We haven't done anything interesting yet. But if we run this, we expect it to always return, this will always return 0. So if we run it, we should get back 0. There it is. Let's make it actually add our start value. So return start. Let's actually just start by returning n, just to prove that we're getting that number back. So step by step, 6. Okay, now let's use start value here. Start value plus n. This is fun. Okay, so if we said 10, we should get back 16. 16. Okay. Now, what happens if we do this? So we're going to play with this to really start to understand what a closure is. So when we're talking about closures, we're talking about the data this function can see. So if I come in here and I have, like, say, const root number is equal to 6, and let's say I'm going to do this, I'm going to run the root number. Now we have this variable here called root number. This function here cannot see root number. Like if I tried to do this plus root number, it gives me an error because root number is not anywhere in the space that this function knows how to see. It's not inside this function's closure. If instead I had my own root number, like here, it can see that. So this root number and this start value, these two values are inside this function's closure. That means this function can reference these numbers. In fact, if I wrote it clearer, I would write the function like this. I'm using this kind of abbreviated syntax. But here's the more explicit syntax. So you can see I'm a function here. I'm referencing start value. It's in my closure, and root number is in my closure, and n is also in my closure here. So these are all numbers that I can see. So I'm going to get rid of the root number here because I don't really want to use it for this example. Okay, so I'm going to do a thing here. I'm going to say const func1 is equal to make adder 10 and func2, actually I should call this one add 10, and this one is going to be add 20. It's going to be make adder 20. Okay, and so now I'm going to call this one with add 10, like that, and then I'm going to call it again, okay, with add 20. So my question is always good to try to predict what's going to come out. It's like, what would you predict this is going to print? Think about that for a second while I have a drink. Okay, let's run. Let's just see. All right, so not too surprising because the code kind of leads you to it. Probably should have left it as func1 and func2, but this is showing that these two functions are indeed different. Even though we called the same function to return them, the start value inside the function 1 is different than the start value inside of function 2. Now this can get more interesting by including a line in here where we can have an internal variable that is special to the functions that we can modify. So let's say we'll have const call count 0, and we will add to this call count, but we'll increment it each time. Why is that not happy? Oh, because I can't. I have to say let. Okay, so we have this call count. Every time we add call count to whatever we're returning, and then we increment call count. So let's just get rid of this guy for now. And let's run this one 3 times. And so let's see what happens. This would be a good one to predict. Okay, so now 16, 17, 18. So what's happening? We are running this piece of code over and over again, and this value is getting incremented. Now we can watch that happen by doing a breakpoint here, and we'll just watch it each time it's called, and we'll see that, we'll inspect it. So, okay, so we're calling doThing from here, and we can see that the value of call count is 0. Okay, then we'll F10, and that'll take us back to doThing, and then we'll go to the next line, and now we're here again. Call count is no longer 0. It remembered, so it started out as 0 when it returned this, but now it's behaving. This right here is behaving like a miniature class. It's just what's special and useful about this class is that this variable cannot be seen by anyone on the outside. With JavaScript, there's enough flexibility that sometimes you can squeeze out what's inside the class. But here, this variable is truly invisible. This internal implementation cannot be pried into, which is pretty valuable. And it's also a lot more flimsy than a class because you just have this flexibility of a function and none of the proper stuff that goes around with the class. And so that's kind of a nice feature of the Lambda is you can make this instant state that goes with the Lambda. Okay, now if we finish this and we do the same thing with add 20, let's put that over here, console log with add 20. Okay, so we should see something similar, right? Because this add 20, it has its own copy of call count. So we should see 16, 17, 18, but we should see 26, 27, 28. So we come down here, and indeed, 16, 17, 18, 26, 27, 28. So this lambda, so this function is making a lambda then that we can then pass around. So this is the essence of how lambdas work. Now let's start talking about like why are they useful? When would you use them? Okay, so let's start fresh here. Okay, so there's this cool thing in so Node and JavaScript. It's essentially an asynchronous language, which means that you don't generally run programs that run sequentially. You generally have work to be done that has to be batched off to the side, and you want it to be done later. So there's the common way that you do this is you have a function called setTimeout. setTimeout takes two arguments. It takes some function f and some number of milliseconds to wait before it executes that. So you might have like a website request that you want to run, but you don't want it to block your program. So like you might have here console.log about to start a web request. Now I'm going to ignore setTimeout for a second, and I'm going to imagine I have a function called function make web request. It takes some URL string, and now this function inside of it is going to do the web call, and it'll return some HTML document. I don't know. Or actually, probably more likely, it's going to return some JSON text, like foo. Oh, that's bad. Dude, some JSON text. Foo bar. Get back. So, all right. So in a sequential world, you would see make web request to some URL, HTTP someplace. All right, and then we would get back the result. result is equal to that. And then we'll say console.log doing, and we'll output it. Okay, we'll say result is, and we'll put in result. Okay, and so this is going to be sequential. You're going to see I'm about to do the web request, and I'll put here console.log making request so you can see what it's happening, and then I'll put the result. So if we run that guy, we should see the sequential output that we'd expect. Oh, we're about to start a request, I'm making a request, and here's the result. Here's the problem. This web request, it may complete, it might not, it could take a long time. And if you want your program to be performant, you would like this web request to not block the rest of your code while it's doing stuff. So that's where the set timeout comes in. So when set timeout works, we'll say set timeout, and it's going to take set timeout just takes an empty callback. It takes a callback that takes no arguments and returns nothing. So it's just basically run some instructions. When you get this, there's nothing to return, but just run some instructions. We'll put them in there. And then you can delay. There are reasons to delay when you call set timeout. I won't explain them right now, but for our purposes right now, we're just basically saying when we pass 0 here, what we're telling the Typescript system is, or JavaScript system, is that, hey, here's some code here that can run offline, do it, and continue executing. Okay, so this code here is going to be where we do this. And then I'm going to put some code here that says hi, doing more stuff. So if this works the way I think it's going to work, this set timeout will finish right away, and all it does is it queues up in the JavaScript system, it queues up this function to be executed as an event later. So what we should see is we should see about to start the web request. It'll call set timeout, but it won't call what's inside set timeout, because at set timeout we're just sending it a function. We're not calling it. We're just sending it some instructions to run, but they won't run right away. Then we'll see this. Then the set timeout will run, and we'll see that output. There's a chance I might be wrong on this, but let's just see. Yeah, that worked. So as predicted, we're about to start a web request, and we do start it like we call set timeout, but we don't see the results of set timeout right away. We can immediately start executing some more code, and then at some later moment, the request starts. And if we want to play around, something that's kind of fun to do to figure out these timings is we can say const time1 is equal to date.now, and then here we can say time2 is equal to date.now, and actually what we need to do is we need to say let time2 0, because I want to see them both, and we'll say time2 is equal to date. So look, time2 is inside the closure of this function. So this function knows how to see time1 and time2. So they're inside their closure. So it'll do more stuff, but we can't check the times. Actually, we should do it here anyway. Okay, console.log time diff. And let's just, for the fun of it, say time2 minus time1. So date.now returns the time in milliseconds. So time 2, time 1 will be the milliseconds that passed between when we ran this function and when this one runs. So we should see a little bit of a delay before set timeout actually gets it onto the queue. So let's see. Yeah, 3 milliseconds. And if we put something here like, 100, let's do 1,000. So this will say, wait 1 second, then run it. Let's see what happens. Yeah, so it waited a second, and then it ran it, and there's that extra 3 milliseconds. So it takes about, so it looks like it takes about 3 milliseconds. I'll bet you it takes 3 milliseconds to print this crap onto the screen. Let's see what happens when I comment out that line. Because a lot of things are happening between the time that we remember time 1 and time 2. Yeah. So the 3 milliseconds is how long it took to print that to the console. That's kind of expensive. So remember that when you're printing stuff to the console. Okay, so all right. So here's a great thing about lambdas is that it's a convenient way to pass some functionality to some other function that's asynchronous. In the past, the typical way asynchronous work was done is it would ask for a callback, and then you would have to like handle the callback when it was done. So you would call the web, make web request, but would have a callback here, which is some function, and then the web request would call it. But the problem with those is they get tricky to wire up. It's kind of hard to follow the code around. This ends up being a little cleaner. And then now we're getting into the realm of promises and so forth. Okay, so let's talk about one more. Let's talk about lambdas again. There's another topic here that's deserving of attention, and that is lambdas with classes and how their closures work, especially in JavaScript, TypeScript world. Okay, so let's say I have a class, my thing. Okay, and my thing has some property on it called, my value 10. And there's also a function on it called my function that just goes console.write or console.log this dot my value. So okay, so if I come in here and I make a thing, thing equals new my thing, okay, and then I say thing dot my function. No, not this. Thing dot my function. Like so. I'm going to expect it to print 10 on the console. So yeah, no surprise there. That's as we expected. Okay, but we can also my function is a function that can be passed around, and the closure for this function includes that value as you'd expect in a class in any language. But classes in TypeScript are a little funky, and there's a gotcha here that will kill you every time that you forget about it. So let's have a function that takes a lambda. So it's a function foo. It takes call me, which is a function that returns nothing. So that's the same signature as this guy. Okay, and then all it does is it says we'll just do console.log. We're in foo, and then we'll see, and we'll call me. So we're going to call it. And so let's do two things here. So we did thing my function to prove that works. Then we're going to say foo, and first thing we're going to do is we're going to pass it some just ordering lambda, and we'll say console.log hello. All right, so what we should see when this program runs is we should see the output of my function, which is 10. Let's go ahead and just put this inside quotes and put some interesting text around it. So we'll say thing value is equal to this guy. Okay. So we are going to call my function. We'll see thing value 10. Then we'll call foo. So we'll see console log foo, and then we'll see thing value. We should see hello, actually, because we passed hello. So let's do that. Yeah, sure enough, thing value 10, foo, hello. Okay, now here's where we're going to show the weirdness. Because I'm going to write a line of code that would work in any normal language that you've probably experienced, like Java, C#, things that have normal typing. This would work. You could say foo thing.myfunction. Okay, this would work in C#. This will not work in TypeScript. So let me demonstrate. This does not work. We get a crash. And it says I can't read my value of undefined. So when this calls my function, it gets into here, and this is undefined. And that is totally unexpected if you're used to programming in another language. I don't believe I have enough details to tell you exactly why this happens in TypeScript, but I think it has to do with the flexible way that JavaScript handles classes. When you just pass this function doesn't really have a concept of knowing that it's part of a class by itself. The concept of this needs to be bound somehow with via a context. And there's two ways that we can do that. So anyway, I've been bitten by this so many times. Like I write it this way, it seems correct, but it's not going to work. So there's two ways that you can do this. One way is that you just wrap the thing in another lambda. And then instead of passing it directly, you just call it. Now, when you call a function on an object this way, so you notice I added the parentheses there. So I'm actually calling it, but I'm not calling it right away because it's part of this lambda. So this lambda now knows that there's a thing, it's got a function on it, and this will automatically set up the this pointer so it'll work. So if we come in here and we run it again, it knows what it's doing. So that's one way to do it. And then another way to do it, okay, so this is typically how I resolve it. There is kind of a cheater way to resolve it, and it's like this. So let's say we for some reason we really like the syntax. I would avoid, well, there's reasons to have the syntax, but you can make the syntax work by changing how this is declared. And so instead of it being a function on the class, you make it a field. And so instead of a function, it is a pointer to a function. So it's just a subtle change. So this is a field on the class that points to a function. Now this is assigned at a time when my function knows what this is. So when the compiler is coming down here and it's reading all this stuff, it makes the it does the work of assigning my function before we get down to this code to call it. So it figures out, oh, this is a function, it needs to be assigned to this value, and it needs to have this. I know that I'm inside this code here, that this is this thing, and so it has access to that. So if you define it like this, instead of defining it as an actual function, then you can use this syntax to call it, and I'll prove that here. So it works the same. Okay, so I think that's all I'm going to say on lambdas right now. I do encourage you to play with lambdas like I've done here. Just make your own little project and just start exploring them so that you can see how they work. Okay, now I will say a few final things about why lambdas are really nice. What lambdas give you is a very shorthand isolation, or a way of encapsulation. So, for instance, I might have okay. So let's make a class here. Let's make a class called radar. We're writing a military application, and then the radar function, the radar class, when you construct it, doesn't really matter what's happening inside radar, but when you construct radar, the constructor wants it. The radar is going to detect things, and you want to tell other people that you've detected them. And let's say in this system, we would like to, launch missiles when we detect an incoming attack. Okay, so a naive way of doing this is inside the radar, we're going to have, maybe some function in here called like process signal. And there's going to be some signal, which is, some number array, it doesn't really matter. Okay, so the process signal is going to do some work. And then at some point, we're going to detect an attack. Okay, now if we're supposed to launch the missiles here, naively, we might just add a function here called launch missiles. And this is a function that we would have imported from some other place, import launch missiles, from NORAD lib, whatever. Okay, and then we would call launch missiles here. That's a very naive way to do it. Like when you're writing code for a class, that's probably the way that you would start writing it, just because it's just so obvious that that's where you want to do it. But radar isn't just used in weapons. Radar is also used to map mountains. It's also used to detect weather. And we don't want to have a thing here to be like, if weather app, then issue tornado warning, else you don't want to it'll make this code super complicated as you go. So what you want the weather app to do is to just what you want the radar app to do is it just knows how to detect the attack, but it doesn't know what to do when it detects the attack. So the way that you make that happen is you come in here and maybe in the constructor you would say on attack detected, and then you might have here attack params. Oops. I'll just call it any for now, and it returns a void. Okay, so on attack detected is passed into the constructor, and we'll remember it here. So we'll have on attack detected, which is of this type. So a function that returns nothing, and we'll just set it, and then inside the constructor we'll say this dot on attack detected is equal to on attack oops, why are you not happy? There we go, is equal to that. Okay, then on the process signal, when we want to have when we detect an attack, we don't know what we're going to let someone else decide what to do. So on attack, oh, oops, this dot on attack detected, call it with signal. So now the radar. So if you're like a weapons installation, you might initialize it like this. You might say const radar system is equal to a new radar, and then it wants a function here. Just do data, and then when it gets an attack, it'll say console dot. Right now, just it'll launch missiles. But you might. So this would be like a defense radar system would be defined that way. But you might also have a alert radar system. So it would be a new radar that takes we pass in a function that takes those parameters, and we might say send attack alert with the details. I don't know, something like that. So the point here is the radar gets to be a radar, and it doesn't have to know how it's being used. The radar is just like, I'm just a radar. I'm gonna like do some signal processing for you, but I'm not gonna decide. It's like I'm the wrong guy to decide what to do with the thing. I'm just gonna detect radar. And then by using these lambdas, you can shield radar from having to know about what you're doing. You're just saying, hey radar, whenever you detect an attack, just run this code. Don't worry about what's in it. I'll handle it. And so we can make different kinds of things that use a radar. And some people, anyway. So, all right, I think that's all I'm going to say. All right, I think that's all I'm going to stream tonight too. So hope that was useful for you folks. I'm going to stop here recording and